Hey everybody, we are going to walk through the materials I use when I design an airplane, and I'm going to use the MSL2 as an example. So, we're going to talk about the plywoods, the balsa wood, a little bit of carbon fiber, and things that I used in this airplane. So, one of the things I want to do is take this 3D drawing as an example here, and we're going to break down the different parts and pieces and dive into this. When you think about the processes and everything that I went through in building this, the most important things was really the types of glue, the type of materials, the type of joints, and let's dive into the fuselage here. And I turned off too many layers there. So when I designed this aircraft, I wanted to create basically a box structure frame that went through the middle of the fuselage, that everything could be built off of it. And it was completely balsa wood. Everything in that was balsa wood. And the stringers were 2 1/4-inch by 1/2-inch pieces laminated together. And I used some carbon fiber on the outside of that because if you know, your strength comes from tension, not compression. The other pieces that went around right there are 1/4 by 1/2. And this was basically a structure made to hold the bulkheads. And if you look, the bulkheads sat on these frames. And when you use a tight bond with the balsa wood, now the bulkhead was made out of light plywood, 1/8-inch light plywood from aircraft spruce. And which I love the light plywood for bulkheads and ribs, and I use the birch plywoods for the firewalls. But when you think about the way the bulkheads were glued around the perimeter of that system there, it was just incredibly strong. Here's an example of the carbon fiber, a little piece of carbon fiber tow I ran down the entire length of the stringer. And if you don't realize it, that just gave incredible strength and rigidity to the system. So when you think about the way that the bulkheads were placed on it, I knew I was going to have outside stringers that ran down the outside of it. But a couple of things I do want to talk about the plywoods is when you think about light plywood versus birch. Light plywood, you can actually bend around and it will curve a lot. The birch is very rigid. And that's the reason I use it for my firewall and firewall box. I've never done all the structural engineering on plywoods and everything. I've read about them all on the internet and stuff, everybody. But look, if you use common sense with this, you can build planes incredibly light. So when you think about, buying plywood, you can go to aircraft spruce, and I buy them in 2 foot by 4 foot sheets of the 1/8-inch, 1/4-inch light ply or the 1/8-inch birch. And the 1/8-inch birch is what I use on the firewalls, not 1/4-inch, because I want to build everything really light. So one thing I do want to touch base with when we're diving into these materials is how important the glue joint is, how you don't want an air gap in there. I use a little bit of CA to tack things together sometimes, but I always use tight bond for where I need things to have strength. I'm not sure why it's the best. It might be because it soaks into the joint because it's a water base. I like epoxy, but epoxy's heavier. And I just love the tight bond, everybody, or the Elmer's wood glue. The Carpenter's wood glue works good too. So now let's think about, this frame that went in the middle here. You don't see the cross bracing here right now, but on the picture in the upper left-hand corner, you see it. That cross bracing was just to hold everything rigid until I put all those stringers on it. Now, once I put all those external stringers on, that thing was incredibly strong. This became just incredibly rigid, okay? Now, I want it to look very much like a 1920s or 30s racer, kind of like a GB-ish fuselage, but I also want it to be long with a longer tail moment, so it'd be a better flying airplane. And when you think about how much of this I wanted to skin and how much of it I want to monocoat, when I put the skin on here, that was all balsa wood with 1/2-inch fiberglass over it. And that was just absolutely light and strong, and it gave me the look I wanted. Now, some people would have probably thought that I would have just, put on a thick fiberglass there to create strength, but I did not need strength. This fuselage is already like a battleship strong. Okay, don't just keep adding things because you think you need it. Try to figure out what you want to do with it. And now, when it comes to tacking some initial parts together like this fuselage, you might want to use a little bit of CA. The part that M is holding up there, I had originally used a little CA to hold some of the parts together, but then as I built the rest of the fuselage off that, I used Titebond. So when you think about looking at a joint, and I want you to experiment with this, like this joint I'm showing you right here, I experimented with. I did a CA joint like that. I used the Titebond. I used the epoxy. When I broke that piece of wood back out of it, it was amazing how much wood came with it with the Titebond. With the CA, it just broke almost like a cold solder joint. And with the epoxy, it took a little bit of wood, but still, it didn't take nearly the amount of wood that Titebond did. I know Titebond takes longer. You got to pin it and let it dry. But if you want a light, strong joint, you want to use Titebond. Now the CA I use is the Gorilla Glue CA I buy at Walmart or Menards. I don't know if it's any different, but I use so very little of the CA anymore. I only probably have one bottle in the house right now. So let's dive into the wing now. The wing was one of the most complicated things I've ever built just because of all the curves and shapes and compound stuff. I had a ton of people tell me that this wing would never work and why I had the big open spaces in the ribs. And, they just didn't understand the design, the way the loads are shared across it. I had two large spars and I had the two inner ribs and the outer ribs that were tied together with that joiner tube. So that was taking the load out to the spars, and on the inside here, it was taking the load to the spars. So I was picking up the spars at two different points. So it was really, really strong, everybody. And I got some video to show you in a minute how much this deflects in the air. But now one of the most important things when I design a wing is the shear webbing. A lot of people don't realize how important the shear webbing is. Basically, shear webbing is like the cross bracing you see on a bridge when you drive over a bridge. Keep in mind, the grain's got to run up and down. And I've had a lot of people tell me I'm wrong until you look it up on the internet. Please do your own research if you think I'm full of it. But the shear web strength needs to be vertical. But I Titebond all of these in. And as I built this wing, it just became stronger and stronger, everybody. But the shear webs are really important. Now, those shear webs, all the balsa I used for thin material was 3/32. Those spars were 1/4 by 1/2 inch balsa wood, and I did run a very 1/8 inch or 3/16 inch carbon fiber toe down the top of each of the spars. So I had a little bit more carbon fiber in there. But keep in mind how things work engineering wise. If you put something in compression, you're normally not as strong as putting it in tension. So when you think about balsa wood and putting it in tension, it's incredibly strong. Okay, and you want your bending moments to come from the top and bottom cord. So if you're pulling an inside loop, the bottom spar is in tension, the top spar might be in a little bit of compression. So if you do the shear webs right, that's cross bracing. So now some people talk about should the shear webbing run up against the rib. It doesn't hurt. I never do. I always leave a little bit of a gap. And from what I've read, a lot of full-scale airplanes are done that way. I like it because I can run wires up and down the wings. If I'm like servo wires and stuff, can get between the shear web and other cavities in the airplane wing. But as long as you tie this all together and it's glued together, everybody, it becomes an incredible system. Now, one thing I want to talk about was the way I tested this wing and some of the deflections I did. So I did take some video after the airplane was flying to see what it looks like. Here, let's look at it real quick here. So right here, as it's doing the pull up here, you see the wing flex a little bit. Over the top, I'm pretty much at 0G. And as I pull out the bottom here, you can see that wing flex. And my guesstimates is about a 2.5 inch deflection. When I tested the airplane, I flipped it upside down, set it on a couple of sawhorses, and put about 4 G's worth of 1 gallon sandbags. So I buy the 1 gallon Ziploc sandbags, fill it full of play sand, and I ended up getting 4-inch deflection, which it's scary, people. You know, if your wing collapses, you've ruined your wing. But I always test my giant scale wings to see what the deflection is. I got about 110 pounds on each wing before I actually started to hurt my fuselage. I didn't have a cradle built to hold the fuselage accurately, but I tested it up to about 4.5 G's, and for a sports plane like I'm flying, it's not going to exceed that unless I'm just really doing something stupid. But I'm really happy with this wing. It worked out great. But keep in mind, everything you see there is balsa wood and light aircraft plywood from aircraft spruce. There were 2 strings across the top of the spars and bottom of carbon fiber, and that's it. This wing weighed less than 6 pounds. I think it was 5 pounds, 8 ounces was each wing. So let's turn on the fuselage here again. And when you think of how to build the lightest you can and the strongest, you need to say, what are you doing? Is it aerobatic? Yeah, you want more strength. If it's a sport plane like this, it's going to fly around, be beautiful in the air. You don't have to have it nearly as strong. This plane ended up being 57 pounds, 8 ounces. And for a 188-inch wing, that's incredible. One thing you need to think about, sorry for stuttering here, but I'm looking at some notes, is how long do your nose need to be on the aircraft when you are designing it? And the reason you do that is the length of your nose helps with your center of gravity. I have never had to add nose weight to an airplane, not one I've designed myself. So, you know, you figure out where the center of gravity, this wing actually is a little bit, it calculates out as a swept wing because the outside airfoil is much longer than the mid airfoil is much longer than the wing airfoil where it meets the fuselage, if I can get that out of my mouth right. So the center of gravity is actually in the middle of the chord where the wing touches the airplane. So when you look at it from the side here and you think about where the CG of this wing is, it's way back there. So I've got a lot of nose out there. So on a light airplane, I've got my battery packs. Now, my flight pack lipos, I could move forward and backwards 6 inches to tweak the final CG, but I never had to add any nose weight to any of my giant scale airplanes. So if you're building your own airplane, try to figure out what it's all going to weigh and think about how long that nose needs to be. So, you know, I've not ever had to put weight in the tail of an airplane. I've never had to put weight in the nose of one I've designed. Another thing, when you build an airplane really light, you can build a lighter landing gear too. Landing gear is one of the biggest frustrations I've ever gone through on an airplane. So up here in the nose, when you think about where you're going to put your receiver packs, your lipo packs, keep in mind you want all of that to be a little bit fluid. You want to be able to slide it around to tweak the final CG. So all I want you to do, though, is think about this. You know, just build planes, people. Design your own airplane and tweak it. You know, it's like when I learned to TIG weld, the way I get better is basically just from being under the hood. And building airplanes is the same. The more you build airplanes, the more you're going to learn. I still think this is the sexiest airplane I've ever built. Just the profile. One thing is the tail feathers on this drawing are not the ones I have on the finished airplane. This was my original stab at it, and I got rid of the idea and went with a much sexier horizontal stab on it. But the wing and fuse are exactly what's on the airplane now. And designing this in 3D, you see a lot of other things. You know where batteries can go. You know where receivers can go. You know where all your stuff can go. I do want to show you right here what the first wings looked like, and they were junk. And these were the second wings I built for the airplane. And you can tell that just completely different with the way they looked. So, you know, one thing I want to talk about when you think about materials, everybody, is it doesn't necessarily mean because the material is stronger, your airplane's going to be stronger. Okay, using a 1/2-inch plywood all over your airplane sometimes is just not needed. Using a lot of balsa wood, especially on fuselage stringers and stuff like that, absolutely is needed. I see people put big, heavy spruce spars in airplanes all the time, not realizing that they need the strength and tension. A spruce spar will probably hold 1,000 pounds, where balsa might hold 400 pounds or 200 pounds. And I'm exaggerating there. People, don't take my word on that. Now, this cowling here I made out of styrofoam, and I put it in my lathe, and I'll show you some pictures here. And I took plastic wrap, and I wrapped all around the foam, and then I fiberglassed the outside of it, and then I took chisels and chiseled out all of the foam from the inside of it, and I ended up with the the rough cowling, and then I basically did a little bit of filler and sanding. It took a lot of time to get it smooth, but I made that from turning it on my lathe, and it worked really, really good. Now the wheel pants I did make molds from, and it worked great. And that's pretty much it, everybody, on this. So basically fiberglass, balsa wood, a little bit of light ply, low carbon fiber, and that's what makes the MSL2. And this is available, this file is available on my website, Infusion 360. And everybody have a great day, be safe, and I'll see you next time around. Bye-bye, everybody. Be safe. Bye-bye.